Okay, so now we'll take a look at conditions, and conditions are something that you'll use quite a lot when programming in R. And the conditions, the idea about them is that they test whether something is or is not true, and that can then be used to select different data from a data set or to get something performed on a specific condition. So what conditions are there? Basically, or at least the most usually used ones, are those that I have listed here. And the idea is that the condition itself, you use the condition command and then you get a feedback returned from R, and the feedback is an answer to the question, is this condition true or false? So in the first example, for example, you can type x less than y, and if x actually is a smaller value compared to y, then you get true returned from R. If this is not true, this condition, then you get false. So this is the way you write the more common conditions. X less than y, that's a less than sign, and greater than is simply greater than. If you want to test whether something is less than or equal to something else, then you use less than equal sign. And greater than or equal, that's greater than equal sign. If you want to test whether something is actually equal to something else, if x is equal to y, then you can't type x equals sign y, because that would mean to R that you want to assign x the new value that's currently stored in y. That is, you take the value in y and you put it into x, and that's not what you want to do. You want to test whether x is equal to y, and therefore you'll have to use double equal signs. X equals sign y. That is a condition testing whether x is actually equal to y, because the single equal sign was already used up for assigning values to x. And if you want to test whether x is not equal to y, then you use the x exclamation mark equal sign as a condition. And of course I'll show you how these works in practice, how they are used. And as you can see in the first case, you assign the value 3 to both x and y. So x is 3 and y is 3. And then you use the condition x smaller than y or less than y. And when you type this, R returns false, because this condition is not met. X is not less than y, because both are 3. If instead you give x equals y, that is, test for whether x is equal to y, then you get true, because that condition is met. X is equal to y. And the last one, x is not equal to y, gives a false, because it's not met. What's great is that you can't only use these conditions on a single set of numbers or something like that, but you can actually test a lot of numbers at the same time. For example, columns in a data set or a data frame. And in this example, we assign the values 1, 2, 3, 4, and 5 to x. So x is a vector containing the numbers 1 to 5. And then you can test whether, for example, x is greater than 2. And x is not one thing, x is actually 5 values. So what you get in return is a vector of true falses. In this case, false, false, true, 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 because it tests each of the elements of x and tests whether they are, in this case, greater than 2. And 1 is not greater than 2, therefore you get a false in return. 2 is not greater than 2, and you get false. 3 is actually greater than 2, and you get true, and so forth. If you instead, which might be more common, you want to get or know what elements in X you actually are interested in the elements that are greater than 2, and you want to know which these elements are, or what they contain, then you could write this way: X and in the position where this condition is met. And of course this is a vector containing false, false, true, true, true. And what R does then is to go into the vector X and collect all the elements with the true. So the first element, which is false, is not used. The second is not used. The third is used because that's true and you get the 3. Fourth, true, you get the fourth element and you get the fifth element. So 3, 4, 5. That's the numbers in X which are greater than 2. If instead you give another condition, for example, X greater than or equal to 2, then you would get 2, 3, 4, 5 in return. So in this way you get all elements that meet the condition. And we have the same X vector here with the numbers 1 to 5. And in this case we make a more complex condition. You actually use 2 conditions and put them together using logical AND. That's one of these Boolean logic operators. And in this case you want all the elements, so you want to know which elements are greater than 2 and at the same time less than 4. And that condition is written as X greater than 2 and X less than 4. And when you run this piece of code you get false, false, true, false, false, because 1 is not greater than 2. 2 is not greater than 2. 3 is greater than 2 and it's also less than 4. Therefore it's true. 4 is greater than 2 but it's not less than 4, and therefore the composite conditional gives a false, and there's a false for 5 as well. And if you want to get the actual numbers, you use the index function. You ask for the X in the positions where this condition is met, and you get a 3 because only the 3 had a true, and only the 3 is both greater than 2 and less than 4. If instead you want to get all the numbers that are not greater than 2, you could write it this way. And as you can see, you put the exclamation mark before X here, and you can do that as well, because what the exclamation mark does is actually just turns all the falses into trues and all the trues into falses. So this takes the condition X greater than 2 and says I want the opposite, that is X not greater than 2, and you get 1 and 2 in return. Here we have the same X still, and we use the logical OR, which is written as a vertical line, and at least in Windows you get it by pressing Alt Graph and greater than sign. You get this sign, which stands for OR. And as you can see, the full condition here is X is less than 2 or X is greater than 4. And you get true, false, 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 true, because 1 is greater than less than 2, and 2 is not less than 2, and it's not greater than 4, so the full condition gives a false. But 5 in the end, that's not less than 2, but it's greater than 4, and therefore the full condition gives a true. If you want the numbers as before, you use the brackets and the indexing function, and you get 1 and 5. These are the elements of X that fulfill the criteria or meet the condition X less than 2 and X or X greater than 4. What's so great about this is actually that you don't have to just give a fixed condition and get all the elements meeting this condition in return, but you can actually use conditions based on something, for example, one column in the dataset, and get in return the values from another column. That's much more useful. And in this case, we make another vector of equal length y. It's 5 elements long, and it contains the numbers 6 to 10. And as you can see here, that's where it gets a bit complicated. You ask for the elements in y that fulfill the conditions, or where the condition x is greater than 3 is fulfilled. And in practice, this function goes into x, looks for all the places in which places x is actually greater than 3. Then it goes back to y, and in the same places it takes the value out of y and returns to you. So because these numbers 4 and 5 are greater than 3 in x, you get true for these, and therefore you get these values, number 4 and 5, in the y vector in return. So you get 9 and 10. And of course this could be very useful if, for example, x or y contain some outcome measure that you are interested in, and x contains, say, ages. Then you can ask for the outcome in individuals with an age greater than 3 in this case.